All right, in this video, I'm going to go through the sample problems that we went through in class. So for this first one, it asks, what is the charge of this atom? Anytime we're working with charge, the only things that matter are the number of protons and the number of electrons. So there's a couple ways you can work this out. You can do it mathematically. Remember, the protons have a positive charge. The electrons have a negative charge. So I could write this out like a math problem. There's negative 18 from the electrons, and then positive 17 from the protons. That gives me a charge of negative 1. Another way that I like to do this is I like to just look at the two numbers. So 17 protons, 18 electrons. There are more electrons than protons. There's one more electron than protons. And remember, electrons have a negative charge, so because there's more electrons, they win, and the overall charge has negative 1. So there are two different ways you can work these out. Let's look at the next one. In the second example here, it says label the following atom as neutral, a positive cation, or an anion. Again, anytime we're working with charge, we're just looking at the protons and electrons. So here, the protons and electrons both have a magnitude of 6. So there are 6 protons and there are 6 electrons. So another way to look at it like this, there are 6 positive charges, there are 6 negative charges. In this case, they're all going to cancel each other out. So we'll end up with a net charge of 0. So this will be a neutral atom. All right, let's look at another one. So in this example, it says, what is the charge of this atom? So again, two different ways we can do this. We can do it mathematically. So we're looking at the positive protons, the negative electrons. So I have a charge of negative 10 from the electrons, and I have a charge of positive 13 from the protons. So that gives me an overall charge of positive 3. Another way to look at it, again, is to just kind of compare the two. So there are 3 more protons than there are electrons. So because there's more protons than electrons, the positive charge would win. And I end up with an overall net charge of positive 3. In this example, it says, interpret the model below. First thing we need to do is we need to look up the identity of this atom. So there are 9 protons. The protons control the identity. Okay, so if you look up number 9 on the periodic table, you'll find that this is fluorine. Fluorine has the symbol of F. The charge here comes from the protons and the electrons. So there are 9 protons. There are 2, 4, 6, 8, 9 electrons. So negative 9 from the electrons, positive 9 from the protons. We end up with a charge of 0. So in this case, this is a neutral atom. The mass number comes from the nucleus. So we're just looking at the protons and the neutrons here. So the number of protons is 9. The number of neutrons is 10. 9 plus 10 gives us a total mass of 19 AMU. The isotopic symbol, first of all, this is fluorine, so it would have an F. And then there are 3 different numbers on the symbol. The first one, the one in yellow, is the mass number. The mass number in this case is 19. 19. The green number is the atomic number, or the number of protons, which is 9. And then finally, that pink number is the charge. Because this is a neutral atom, I don't need to put anything there in the pink. So again, mass is the yellow number. Protons is our green number here. And then the symbol is the symbol from the periodic table. All right, let's look at one more example here. It says interpret the model below. Very similar to the one we just did. So the first thing we're going to do is we're going to look at the number of protons, This has 12 protons, and if you look on the periodic table, number 12 is magnesium. Okay, so to determine the charge, let's look at the number of protons, and then let's also look at the number of electrons. So I count 2, 4, 6, 8, 10 electrons. So we have 10 from the negative, we have a negative 10 from the electrons. And then for the protons, we have 12, so plus 12. So there's a difference of 2 between these. And since there are more protons than electrons, we're going to end up with a total net charge of positive 2. So a normal neutral magnesium atom has 12 protons and 12 electrons. In this case, we have 10 electrons down from our normal 12. So in this case, we lost 2 electrons from the normal neutral magnesium atom. The mass number in this case comes from the middle. Remember, the middle has the protons and the neutrons, the nucleus. So 12 protons plus 12 neutrons gives us a total mass of 24 AMU. And finally, our symbol, magnesium, Mg, comes from the periodic table. And again, like the previous example, we have 3 different numbers we need to fill in on our symbol here. The top number is the mass number, so that's going to be 24. The isotopic symbol, not the isotopic symbol, the green is going to be the number of protons, which is 12. And then finally, the charge goes in that pink box. The charge we figured out was plus 2, or 2 plus. And that is how you write out the isotopic symbol. So these are the 5 examples that we did in class. If you have questions, please hit me up during office hours